This is Module 7. The question asks you to determine a sequence of outcomes for 3 spins that will yield a mean of 8.33333. Okay, so the important thing to consider for this question is that the only outcomes that are possible for a single spin are 1, 3, 5, 7, and 9. Okay, so in what ways could you get a spin that has a sample mean equal to 8.3333? Because there are 3 spins, the sample mean is computed as the sum of all 3 spins divided by 3. So to know what the sum of the 3 spins has to be, you have to multiply 8 with 8.33333 by 3, and that gives you 25. So you want to have the sum of your spins be equal to 25. Okay, so if you look at the numbers here, given that you can only have 1, 3, 5, 7, and 9, you have to have 2 9s here. Okay, so 9 plus 9 plus 7, that gives you 25. If you have 9 plus 9 plus 9, that's 28, or sorry, that's 27. You can't have 9 plus 7 plus 7, that's just not going to work. I mean, there's only one way here to get 25, and that's to have 9 plus 9 plus 7. Okay, so the first spin will have to be, the outcome of the first spin should be 9. Okay, the second one, 9. And the third one, 7. That's the only way, given these outcomes, that you can get a sum of 25, which divided by 3 gives the desired mean. Okay, what is the probability that the mean of 3 independent spins is 8.3333, specified in 4 decimal places? To do this, you have to figure out the way in which you can get a sum of 25 from the 3 spins. And so, in other words, you want to know how you can get 9 plus 9 plus 7, or how many ways there are of getting these 3 values on your 3 spins. Because you can divide this into 2 outcomes, so you can either get a 7 or not a 7. You can use the factorial equation to come up with the possibility, or the number of ways in which you can get 2 9s and a 7 in 3 draws. So if you remember, it's n factorial divided by y factorial times y minus, or n minus y factorial. So it'll be 3 factorial divided by 1 factorial times 2 factorial. That'll give you 3. So there are 3 different ways of getting 2 9s and a 7 out of 3 spins. Okay, so you multiply that by the probability of 1 such spin. In this case, the probability of each spin, so the probability of getting 9 is equal to 1, because 9 is between 8 and 10, 1 out of 5. Okay, so to get 9 on the first spin, 9 on the second spin, 9 on the, or 7 on the third spin, each spin is equally likely. Each spin is equal to 1. The probability of each spin is equal to 1 over 5. So you can take 1 and divide it by 5 raised to the power of 3. And you can multiply that number by the number of sequences that will give you the desired number of 9s and 7s. We already said that was 3. Okay, so the probability of getting a sample mean of 8.33333 with 3 spins is equal to 0.024. Okay, what is the height of the probability density function for a mean of 3 spins, which has that that's equal to that number? Remember that probability is height times width. The probability here is 0.024. The width, you're told here, is 2 over 3. Okay, so height is going to be probability divided by width. So you have to divide 0.024 by 2 over 3. Okay. Okay, and that gives you a number equal to 0.036. Okay, the next question says you have a population mean of a rectangular distribution. It's equal to 5. The standard deviation is equal to 2.88675. And you draw a sample of values from this distribution with a sample size n is equal to 26. So that's large enough for the sample mean to be normally distributed. Okay, and in this example, what is the standard deviation of the sample mean? The standard deviation of the sample mean is equal to the standard deviation in the population, which is 2.88675, divided by the square root of n, which is your sample size, in this case 26. And I'm just going to round that up to 6 digits. Okay. Now here it says let x be a random variable whose distribution is roughly, okay, so it's not excessively skewed, has a certain mean, a certain standard deviation. You draw a random sample from this distribution. That's the size of the sample. Suppose the sample mean is 7.91. Specify this probability of observing a sample mean that is greater than or equal to this value. This is not too different than the questions on Module 6 where you have to convert a certain score. For Module 6 it was an X. Here it's really the sample mean. You have to convert it to a Z-score and find the probability under the Z distribution. In this case, that corresponds to a Z-score that is equal to or greater than the Z-score corresponding to the sample mean. So I'm just going to do this on Excel. Okay, so the mu is 7.9. Sigma is 11.39. Now n is equal to 74. The sample mean that we're interested in is 7.1 or 91. I just want to check if this was done correctly, and it wasn't. Okay, so it's Z is equal to Y bar minus mu divided by sigma, which itself is divided by the square root of n, and that is the Z-score, 0.007. If you round it to 2 decimal places, it's 0.01. So again, you can go here. Okay, the odds of getting that mean or higher is equal to the non-shaded region, so 1 minus 0.504 is equal to 0.496. Oops.